Hello everyone, welcome to the design of steel structure classes. In this video I will going to explain how to design a column base or base plate for the given column. Okay, so now I will take out the question. So this is the question. Now I will read out. Design a slab base for the column ISHB 450 at 87.2 kg per meter, which carries a load of 1000 kilonewton. Take the grade of concrete as M20. Assume Fe 410 grade steel. So your ultimate capacity of steel is 410 MPa. Fe is equal to 250 MPa. So here the question. In this question we need to design a slab base or base plate for the given column. The column is given. Okay. So now I will see the step-by-step procedure. So first step. In this first step we need to calculate area of the base plate. So area required for the base plate we have to calculate it. So this is the formula to calculate the approximate area required for the base plate, that is PU divided by FBR. FBR means bearing strength of the concrete. So you know the factor load. So working load is P is 1000 kilonewton. You can multiply it with 1.5. So you will get the factor load. Then after that you can calculate the bearing strength of the concrete. FBR is 0.45 FCK. So 0.45 FCK is 25. You can multiply it with, you will get the 11.25 PA. That is bearing strength of the concrete for M25 grade. Okay. So here after that you can multiply those values in this formula. Approximate area required, that is PU divided by FVR. Okay, after calculation you will get the approximate area required for the base plate. Okay, so after calculating the approximate area, so now the next step is you have to calculate the dimension of the base plate or slab base. So in the next step, in the question itself that given the column, so that is given column is 450 at 87.2 kg per meter. From the steel table you can write down the properties of the given section. So the D value, width of the flange, thickness of the flange, thickness of the wave. You can write down from the take down from the steel table. Okay, so this is your I section. So this is the base plate or slab base. So here the 250 the breadth of the flange and 450 D value. So this will be the thickness of the flange is 13.7, thickness of the web is 9.8. So this the 40 mm is the extra projection in the both in the x direction as well as in the y direction. See here in both the direction at the both the side we are providing 40 mm. In longer direction also here 40 mm, here 40 mm. So we are providing the extra projection here. See here, let us assume an equal projection of 40 mm behind the column in both the direction as shown in figure. So this will be the base plate or column base. Okay, so now you can calculate the total length into bend. This will be the length and this will be the breadth. So length is 450 plus 40 plus 40. Here this is 530 mm. Breadth is 250 plus extra projection 40 plus 40. 250 40 plus 40, that is 330 mm. So 530 by 330 mm, this is the actual area. So now in the next steps you can calculate the actual pressure below the base plate. Okay, so W is equal to PU by L into B, or actual area. We know the PU value and also we know the L into bed. Substitute those values, you will get it 8.58 Newton per mm square. So this will be the actual pressure below the base plate. So this will be the less than that FBR. FBR means bearing strength of the concrete for M25 grade. So FBR will be 11.25. So you already calculated in the first step. See the bearing strength of the concrete, that is 11.25 MPa. So this is less than this value, hence it is okay. So after that, so next step is calculation of the thickness of the slab. So to calculation of the thickness of the slab, the formulas is given in the IS 800 2007 in the page number 47. Here this is IS 800 2007. So this is the page number 47. You can see the class 7.4.3.1. So thickness of the slab, that is equal to square root of 2.5 w, open the bracket, a square means 0.3 b square, close the bracket, gamma m naught divided by whole thing fy is greater than thickness of the flange. Okay, see here w is equal to uniform pressure, we already calculated. So a and b is the larger and smaller projection, that is 40 mm already provided. Now you can substitute the values, that is 2.5 into w value already calculated, that is 8.58. So this is a and b value. See, this is the projection in the breadth side, that is the a. The projection in the longer side we called as b. Okay, the both the a and b will be same value, that is 40 mm. So after that you can calculate. So you will get it 10.28 mm, but it should be a greater than thickness of the flange. But is the thickness of the flange is 13.7 mm for our given section. See here, so thickness of the flange is 13.7 mm for our given section. So here you are getting thickness of the slab is 10.28. So from the steel table, that is 13.7 mm. The TH should be is greater than thickness of the flange. So you can provide the 50 mm. So it should be greater than this. So means 15 mm. So let us provide the dimension of the slab base plate is 530 into 330 into 15 mm. So this is the actual dimension for the slab base plate.